Lesson 31, Geometric Sequences. All right, so last time we were talking about sequences that would be something like, 2, 4, 6, 8, going up by some number, right? Now what we're going to be talking about is a little bit different. Let's say our numbers are more something like 10 and 20. So, kind of starts out the same way, but then our next number is going to be 40. And then our next number is going to be 80. And then 160. Can you kind of see the pattern that's happening here? It's, well, I won't get to it yet. So first off, like this is where we're headed, or what we're going to be doing. These are called geometric sequences. And hopefully you watch that video about folding a piece of paper and how far it will actually go, because it really starts to break down our intuition. So you start to say, like, how many times as this sequence carries on, you get these astronomical, literally astronomical numbers that start to come up because they just become so big so fast. This is called geometric sequences. And geometric sequences, what that really is a sequence in which, I'm gonna write this down with me. So a sequence in which the ratio of consecutive terms is constant. And I know that probably doesn't make much sense right now, but it will as we start to come up with our formula here. So the formula that we're going to be using, so it's going to be Tn, so kind of look the same to begin with, is equal to T1 times, and I'll put this in brackets maybe just to kind of make sure we know what we're doing here, times R, that's a new thing, and then n minus 1. So all the things here are the same as what we've been doing. R is the kind of the new thing. So let's just go through again what these things mean. So T1 again is going to be the first term. So nothing changed there. N again is going to be the number of the term. Not hashtag of the term, number of the term. R, our new thing here, this is going to be a common ratio between any two consecutive terms. And let's break down what that means. So let's go back up to my example up here. So common ratio between any two consecutive terms. So remember, these are terms. So it's saying common ratio between any two consecutive. Consecutive just means two beside each other. So if I took the ratio of 20 over 10, so 20 over 10, well, that's 2, right? If I take the ratio, let's say, of these two consecutive terms, so 40 over 20, well, that's 2. What if I go 160 over 80? Oh, 160 over 80. Again, that's 2, right? So that's what we mean by that. So that's what's happening. That before, when we had our sequence that was more like 2, 4, 6, 8, 10, we were looking at the difference between these two, right? Between every one of them. Now what we're doing, you can think about, is like multiplying and dividing. We're looking at the like dividing these two. Well, what did I have to multiply to get from this one to this one? What did I multiply to get from this one to this one? So in this one above, we had to add 2 every time. So plus 2, and plus 2. Now what we're doing is we had to multiply by 2, multiply by 2, and multiply by 2. So that's really the only difference here so far. Okay, so that's our new formula. And then Tn, I'm not going to write it down. It's just the number that it's going to be at when, let's say, so if you had like the 5th term, so n was equal to 5, that'd be what that term was. So the number of it, or the actual value of it. All right, so for the following sequences, write the general term for that sequence. So we're looking at these. We're going to use our new formula. So we'll start out by saying, not capital, Tn is equal to T1 times R to the power of n minus 1. And let's maybe just put these in brackets so you know just numbers go in there, right? And that this n minus 1, that only applies to the R in this, not to the T as well. Okay, so let's write down what we know. We know T1 is 2. We know, well, we want to leave n and Tn, right? Because we want to make a general term with those things in it. But we do want to know R. So let's figure out what R is. So R, in this case, what did we have to multiply to get from that to that? What did we multiply to get from that to that? Or what I find easier is, what do you get if you divide the thing on the right by the thing on the left? So every time you do that, it looks like 3, right? I had to go 2 times 3 to get to 6. I had to go 6 times 3 to get to 18. So R is going to be equal to 3. So now let's just plug stuff in. So Tn is going to be equal to, T1 was 2. And then R was 3. And then n minus 1. Now can I be like, okay, and I just need to now multiply 2 and 3 together? No, you can't. They're not common. They're not like terms, right? This n minus 1 that's that the 3 is being to the power 2 isn't the same as this 2. So we can't just go around multiplying those. So we just got to leave it like this. So yeah, you might see it written without brackets on the 2 out front. It'd just be like something like that. But yeah, that'd be it. Okay, so determine what the 10th term would be. So let's put that in. So we go t to the 10 is equal to 2 times 3. And then up top, my power is going to be 10 minus 1. So this would become 10, or t10, the term at 10, is equal to 2 times 3 to the power of 9. So if you put that in your calculator, I get 39,366. So there's that. Oh, and I should have shown that for my general equation too, or general term. All right, next one here. We're going to start off with our formula. It's equal to T1 R n minus 1. Okay, we know the first term. It's going to be 3. We know R. Well, what is R here? What did I... If you go negative 6 divided by 3, you get negative 2. Same with any of these. Negative 24 divided by 12, that's also negative 2. So R is going to be negative 2. And then to the power of n minus 1. And that'd be my general term. Okay, to the 10th power, that'd be t to the 10 is equal to 3 times negative 2 to the power of 9, right? 10 minus 1. And I get t 10 is going to be negative 1,536. So notice with some of these sequences, you start to see a pattern, right? If you have a negative R value, then it starts to alternate positive to negative, positive to negative, positive to negative. Okay, just a pattern that we kind of start to see. Last one here, it's going down this time now, right? So let's see if we can see what this pattern is going to look like. So Tn is equal to T1 times R to the n minus 1. T10 is going to be, so our first term is 64. What's R? What did we, if I went from this to that, so 16 divided by 64, let's just kind of see, like if we, let's say we divided both things by 4, right, the top and bottom, so they can both, 4 can go into both of those. This would end up being 1 over 4, and that's what it is, right? So we had, it was a quarter. So you can kind of think about it like that, or you can think about it as that I had to divide by 4 well, actually, sorry, you had to like multiply. So 16 multiplied by 4 to get to 64. So it's kind of the opposite. So all you really have to do is just go 1 over whatever whatever it was. Or you can think about going from left to right. That's when you'd have to go 1 over 4. So however you got to remember that. Okay, and then up top here, we're going to have n is going to be 10 minus 1, so 9. So we've got T10 is going to be equal to. So you end up getting 1 over 4,096. So a really small number, right? This would also be a really, really small decimal if you actually found the decimal of that. And that's kind of what happens here, right? We're never going to get to 0. You can see what's happening here, that if you go 64 divided by 4, you get 16. 16 divided by 4, you get 4. 1 divided by 4, you get a quarter. And no matter how many times you divide by 4, you're never going to get into the negative numbers. So it's just going to get closer and closer and closer to 0. So if you were to kind of graph this situation, and this was 0, it would look something like this, right? Where you have an asymptote that's never quite touching 0. All right, moving on. Practice problems. All right, so bacteria reproduce by splitting in 2, so that one cell gives rise to 2, then 4, then 8, and so on, producing a geometric sequence. Suppose there were 9 bacteria originally present in a bacteria sample. State the values for T1 and R in the geometric sequence. So this might help to kind of think about it. If you had, not 9, we'll just kind of put that on hold for a minute, but let's say you just had 1 bacteria in there. So let's write that one out. So if we had like 1, that would turn into 2, that would turn into 4, which would turn into 8, which would turn into 16, right? So our R value for this is going to be 2, right? Because if I go 4 divided by 2, I get 2. If I go 8 divided by 4, I get 2. 16 divided by 8, I get 2. So I get 2 for all of those. So that's going to be helpful if we figure out, so R is going to be equal to 2. And we also know that T1, it says we start with 9. So that's going to be 9. Oh, not 9 is equal to 9. T1 is equal to 9. So what's really happening here is that we are going to start at 9. And then what would our next number be? Well, the easy way to do it is multiply by 2. So it's going to be 9, 18, 36, 72, and 144. So that's really what's happening here, right? Here's our sequence. So now determine the general term to the geometric sequence. So just need our formula. So Tn is equal to T1 times R to the power of n minus 1. So Tn, let's leave it like that, is equal to, T1 was 9, R was 2, and then n minus 1, and that's it. Okay, in a geometric sequence, the third term is 54, the sixth term is negative 1,458. Determine the values of T1 and R and list the first 3 terms of the sequence. Okay, so what I recommend doing for these ones is kind of sketching it out the best we can here. So let's make some blank spots here. It says we're going up to the 6th term. All right, and we know the third term is 54, and we know the last term is negative 1,458. All right, so determine the values of T1 and R and list the first 3 terms of the sequence. We need to figure out what R is, but how did we get from 54 to that? Well, how would we go from 54 to the next one? Well, we would multiply by R, right? So we'd go 54 times whatever that R value was, and that would give us the next one, right? So let's maybe go step by step here. So I would go 54, I would go times R to get to that one. So if I wanted to get to the next one, I would go 54 times R, but then times R again, right? Because that would, times R would get me to this one, and then times R again would get me to this one. So if I was going to get to this last one here, I'd go 54 times R, and then times R again. So times r one more time. So really my formula, I can make it a little formula here. It's going to be 54 times r times r times r is equal to negative 1,458. And then lastly, let's just write those three r's all being multiplied by each other. I can write that different. I can write that just as r cubed is equal to negative 1,458. Now, why was that helpful? Well, because now I can just solve for r. So let's divide both sides by 54. So divide by 54. So that ends up being negative 27. So r cubed is equal to negative 27. Now, what do you do with that? Well, you do the opposite. So if I want to figure out what r is, I'm going to take the cube root of both sides, right? So that gets rid of the cube. So cube rooting a cube cancels them both. And cube that side. So we end up with r is equal to the cube root of 27. That is negative 3. Okay, so that was kind of the hard bit there. Now, what I would recommend doing again, let's just write our, like what we have here. We know this was 54. We know the last one was, oh, I need one more. Nope, I wrote the wrong one. The last one was 1,000. Okay, so now that we know what r is, though, it's easy to go one way or the other. We can just go 54 times negative 3. That's going to get you to the next one. So we get negative 162. And then if I just go times negative 3, that's not x, it's times now, negative 3, you get 486 that way. And if I want to go back, because it wants t1, right? T1's the other thing we're looking for here. I just need to divide by. So if I'm going to go that way, I just need to go divide by negative 3. So 54 divided by negative 3, negative 18. And then negative 18 divided by negative 3 is 6. Right, so that's T1. We figured it out. And R. The other way we could do this, though, is we could go back, like without drawing like the picture like that and doing it. We could set up the formula. To make a different color here. Tn is equal to T1 times r times n minus 1. And I could look at spot number 3, 54. So if I do that, we can figure out T1 here by going, okay, well, Tn at that point is 54. T1 is what we're looking for. R I know now is negative 3. And then at this point, this is 3 minus 1, so 2. Right? N minus 1. So then if we do that, we've got 54 is equal to T1 times negative 3 squared is positive 9. So let's put the 9 out front there. Divide both sides by 9. And we get 54 divided by 9 is, oh, not 9, 6. Upside down 9 is equal to T1. So we also could have done it that way as well. Yeah, so however you feel more comfortable. Okay, 3. The town's population is 10,000. It's increasing at a rate, so R, or it's related to R anyway right now, of 2.5% every year. Determine the general term created by this geometric pattern. All right, so off the bat, though, I want to show you what it would look like if it wasn't increasing at all. So we start off with our formula. Tn is equal to T1 times R times n minus 1. Okay, now if R, let's do just kind of fill some things in here. So if we had Tn was equal to T1 was 10,000. Let's say that R was 1, right? That's our ratio we're going to say. It's just equal to 1. Well, 1 to the power of, no matter what n minus 1 is still going to just be equal to 1, right? So it's just, so that's what it is. So it's just equal to 1. So no matter what there. And the reason why I did that, let's say equal to 10,000. All right. I just want to lead up to something, because now if we look at this a little different, we're going to say Tn is equal to 10,000. And now the ratio I'm interested in is keeping it at the same level at 10,000, and then it's increasing. So it's got to be like 2.5% on top of 1, on top of that, like, you know, just original base value. So instead of writing in brackets here, you know, like you'd write a percent. Well, first off, you'd write this as a decimal, right? So 2.5% would be 2.5 over 100, right? That's what percentage means. So that would be equal to 0.025, right? That's another way of writing it as a ratio. But we're not going to write it like this. We're going to write it as 1.025. Now, why did I leave the 1? Like, why 1 point? Well, because I need to have that 10,000 and then 0.25 on top of that, or 2.5% on top of that. So that's what, when it's increasing, this is going to be 1. All right. Now, to the power of n minus 1. And that's it. So now let's look at when it's decreasing. So same question, but it's just now decreasing. So it's going to be Tn is equal to T1 r to the n minus 1. So now what goes in for r? Well, for r, I want that to be 10,000 and then like minus 2.5, right? I want like 2.5% coming off of it every time. So how could you do that? Well, it's going to be 1, right? Like 1, like keeping it at 10,000. That's what like one whole population would be. And then I'm going to just subtract 0.025, right? So this is going to be 0.975. So you can see that if you're multiplying T1 by an R value that is less than 1, it's going to decrease. If that value is more than 1, like we had it in that one, it's going to increase. So that's kind of, yeah, there's a difference between increasing and decreasing here. So let's just write this out finally as Tn is equal to 10,000 times 0.975 to the power of n minus 1. Okay, you have a photo, I should say, that is 25 centimeters. The smallest size of a certain photocopier can reduce a photo as 67% of the original. To the nearest tenth of a centimeter, what's the shortest possible length of the photocopier after 5 reductions? So you have a photo, you're going to make it 67% the size that it was. Then you're going to take that one and make it 67% the size it was. Then take that one, make it 67% the size it was. So that's kind of what's going on here. So first off, though, I just want to make sure you know what we're... So if this was my original photo that was 25, right? I just want to draw your attention to this. So after 5 reductions, so after 1 reduction, that would be this spot right here, right? So we're going to say reduction 1. So we'd call that T1, right? Maybe that could be T1. So after 1 reduction, after 2 reductions, that'd be T2. After 3 reductions, that'd be T3. And then T4, and then T5. And the reason why I brought that up is because how many spots do I have? I got 1, 2, 3, 4, 5, 6. So that's why if we're looking at 5 reductions, you can do this 2 different ways. You can think about this as saying, okay, we're just going to start with T1 as being this spot right here. So to find T1, how do you find a percentage of a number? So I just want to find 67% of 25. Well, you write 67% as a decimal, so I'd say T1 is equal to 0.67, and then multiply that by the number, so 25. So T1 is going to be 16.75. Okay, so that's what you're doing. So we could say that's T1. Or if you wanted to treat this question a little bit different, you could also just change this to 6 if you wanted to. It'd be 6 reductions. And then you could call this T1 if you wanted to, just because there's 6 spots then, right? So hopefully that made sense, like what I'm talking about there. Just because there's actually 6 spots there. So when it says 5 reductions, you have to be careful not to make a mistake there. Okay, so anyway, we're going to just carry on that T1 is the second column because it's the first reduction. Okay, anyway, so that's T1. So now let's just start out with our formula. We got Tn is equal to T1 R to the power of n minus 1. Okay, so we're going to say this is T5, so the length at 5. T1 was 16.75. R, we're going to say, is 0.67. It's getting smaller, right? So it makes sense. It's below 1. And then N was 5 minus 1, so let's change that to 4. So we get T5 is equal to 3.4 centimeters. And I'm just looking at how long that video was. Sorry about that. Here's your key ideas, just to make sure that you know these things. R, don't get too confused by this. You know, we just kind of talked about it as being like if this was 2 and then 4 and then 8. We said like 8 divided by 4 gave you R, or 4 divided by 2 gave you R. That's what this is saying. T to the n divided by the next one down in the sequence, n minus 1. So that's all it's saying. And then we got the same formula, and yeah. So make sure you guys do these questions now for your assignment. So that's going to be it for that video.